And Sarah is going to go from the field and orchard style to processing to kind of show the step-by-step progress on Pawpaws. She will also be available throughout the tours and throughout the day as well. So, Sarah Francino.
Hi guys, wait 1 second, let me make sure that all of this is working. Okay, doesn't seem like it is. That's okay. First off, I really wanted to thank our sponsors and our funders, specifically the Ohio Department of Agriculture, USDA NIFA, and the NCRS SARE grant, which have all funded my research and me being here. I would also like to thank the North American Pawpaw Growers Association for all of their help. Ron Powell, Mark Stadler, who's somewhere here, and Lauren Kitchener and Mabel, who have all helped me pick fruit and get fruit from their orchards and allowed us to actually do this processing work, because it takes a lot of fruit to run some of these machines. So, it's showing up. Why invest in processing? As many of you know, Pawpaw has large variability in sizes of fruit and many characteristics. We have two different types of fruit. Generally, we have cultivar fruit that are grown open in open settings, and then we have wild fruit. We also have a very short shelf life of the fruit, and we want to get the best return for growers in the long run. Over the past 5 years, we've seen around 100 acres of pawpaws put in by new pawpaw growers, but also by fruit growers that have been established, who are apple growers or other people who grow fruit. And they will expect a market for not just their premium fruit for fresh growing, but also for their drops and their smaller fruit. Orchard-grown fruit has more consistency and large fruit, but it requires a lot more maintenance, which is a trade-off which you would have to think about. And the variability in this fruit does cause some problems, especially the seed size, which can vary from very tiny seeds to very large seeds. And then also the skin thickness, which, because they're so thin, the fruit gets easily bruised. But also moisture in the fruit, that could lead to different consistencies, and we have different sizes of the fruit. Some of the particularities that Matt talked about when the fruit is misshapen can also cause problems in processing. So, why we're interested in wild versus cultivars. I hope you guys can hear me. I feel like this mic is not very close to my face.
You're good, you're good.
The wild and cultivar fruit have different properties. Wild fruit, when grown under shade, these trees can reach 20 foot tall, and they can get 20 foot tall in the orchard, but you don't have a canopy over you. You don't have the trees competing. You can take ladders out more easily. And the usual colloquial knowledge is to shake the pawpaw trees to get the fruit down, but then they fall on your head, or they bruise or they drop on the ground, and that all can be a process. So, but they're still a good source of pawpaws, and Gil has been able to estimate that about 50% of the fruit is coming from wild trees. So a lot of that is getting to market, and we want to make sure that there's a way to process this fruit, wherever it's coming from. And the wild fruit can have some off notes, some different flavors that might not be in the cultivar fruit. The big thing about the cultivar fruit is that when you have that genetic material growing up, you know it's going to be consistent flavor. There still might be some environmental factors that change, like talking about irrigation, that might change the fruit moisture. If it's deficient in nutrients in one place or another, that might change the flavor slightly, and that would differ also by cultivar. I'm pretty sure they changed PowerPoint so it doesn't do everything like it did previously, but so why we were looking at domestication. Somebody asked about rootstocks earlier. So apples have been domesticated for thousands of years. Pawpaws are very short in their window, about 200 years they've been in the domestication process. Previous to that, native people used them for rope and for eating, but they haven't been tried to be grown in orchards in a meaningful way until like the past 100. So this short shelf life problem that they have, because they only last 3 to 5 days on the counter, depending on how much of a caramely rich flavor you like in the fruit, it can be very problematic. Yet refrigeration can increase the shelf life to 2 to 4 weeks, but that still, as you get closer to that 4-week period, you're getting a more caramely flavor of fruit, you're getting different quality characteristics. The softness of the fruit and the short shelf life also causes transportation problems, and we haven't really had good understanding of how to mass process fruit. But this is the point where it all comes back to, there's lots of pop products out there. We've got liqueurs, hot sauces, beers, jams. There is even a pawpaw extract, which you can take, which is interesting. And then also frozen pawpaw pulp from Integration Acres. All of these things are made from pawpaws. And the current market is supply limited, with the demand for fruit and pulp very, very high. When fresh fruit is sold to farmers, you always will have some that doesn't sell at market or needs to go into a secondary process. So that's what we are trying to look at so that we can continue to grow this market, help farmers supplement their income, and also make it less risky for people to grow pawpaws. Because if we know how the process for processing them, then it will be able to be implemented by many different people across the board. Okay, so some other considerations that we want to make before processing. What is the time investment in different types of processing techniques? There's going to be a different investment in equipment, and there's also going to be an investment in storage of the pulp. Your time investment will be different for each person, and also your investment in how much you want to invest will be different for each person. The storage of the pulp is not something that you're going to be able to get away from. So if you decide that you're going to process 100 pounds of pawpaws in X way or in B way, you're going to be storing it both in the freezer, and that's not going to change as much as the other two considerations. So our research objectives was to find the most efficient peeling method and the most efficient pulping method, along with looking at the storage methods to see if we could increase that shelf life in the freezer. So we started out with peeling. We took 2 cultivars. We took Susquehanna and Sunflower, which are 2 staples. They have slightly different physiologies. Susquehanna is usually a little bigger, Sunflower is usually a little smaller, slightly different colors of fruit. And then we tried 5 different methods. These methods were, after I had a very long conversation with Ron Powell and talked to many other people in the pawpaw industry, trying to figure out what the best method, like what the methods out there would be even. So the traditional method is scooping, so that's cutting the fruit out and scooping the fruit out from the skin. Knife peeling is peeling the fruit with the knife from the outside. So it kind of looks like a gem. We'll look at the pictures here. Blanching is throwing the fruit into almost boiling water to remove the skin from the fruit itself. This is done with tomatoes and peaches in large processing operations. And then I had two out there suggestions from people. Someone suggested that I should throw them in the microwave to try to remove that skin from the fruit. Didn't work out that well. I have also, since I started, heard of people throwing the whole fruits into the freezer and then thawing them so that they could then remove the skin later and process it later. So we tried all 5 of these. It was interesting. We replicated the experiment. The first time we ran through them all, it was definitely a learning process, which is always with processing large amounts of fruit. The first time you do it is a learning process, and you should always give yourself that time to be just like, okay, we're going to do a small amount, we're going to see how it works, see where the kinks work out. But you can see the differences here. This is blanching. You can see how the fruit, and this is Susquehanna, so the fruit are kind of dark orange. You can see the outsides have browned a little bit, and you can see also with the freezing that the outsides have browned a little bit. But you can see the knife peeling. I'm not sure if it's translating that well onto the screen, but you can see how they kind of look like gems because the knife has taken off a little more of the fruit. And this is the traditional scooping method, which was how I learned how to do processed pawpaws in the first place. So we started off with different weights of fruit because the fruit are different sizes, and to get them the same weight would have been a pain in the butt. But we also ended up with different pulp weights. Let's see, where's my work? Yes. Here. So really what we were focusing on was the recovery percentage of the pulp and the efficiency. Again, we are aiming for the most efficient method. And I'm not sure how to get my face off the screen here so we can see that last 2 thing. Oh, so the pulp recovery rate, you can see that we had they were significantly different from each other. And the significant difference was between freezing and blanching and between knife peeling and blanching. So this shows us that blanching had the most recovery, which if we go back, laser cutter works at least. See, the blanching, you can see that the fruit does not have as much taken away from it, whereas the knife, you can see the knife will take away more fruit. And then in efficiency, what you cannot see is the freezing down here, which is slightly sad, but that's fine. The knife peeling is the least efficient method, whereas blanching is the most efficient method with being at 4. So this led us to believe that blanching was the most efficient method. And this was work we did in 2021, and we had then just tested out the pieces of machinery we're going to use for pulping to do a full pulping experiment. So going forward, we compared pulping. At first we were trying to find some new methods of new machines to use for pulping. We tried a food mill, we tried this honey press, and neither of them worked very well. It was very disappointing, and so we came back to recommendations that we've had from other people previously, which the traditional method is hand pulping here, which is just using a mesh bag to squeeze the fruit through. A tomato processor, which has been touted by the OPGA previously, and then KSU has recommended the Roma Coupe previously to be a commercial processor. So we wanted to test these 3 against each other to see how efficient, what was the most efficient method, and how they compared in the processing in a processing lab setting. So hand pulping, we first, for all of our fruit, we put it into a KitchenAid mixer. Whoa! I shouldn't talk with my hands. We put it into a KitchenAid mixer and beat it for about 5 minutes. This helped release the seeds from the fruit itself, and there is a seed coating around the seeds, which is not very easily taken off, but you can recover it in the Roma Coupe. So this helped remove those seeds, and then when you're hand pulping, it's just a lot easier on your hands. This was the trial year, and the year I got pictures of hand pulping, but you should be wearing gloves and being sanitary, so don't wash your hands, guys. But, so then we took the resulting pulp, and we put it into a mesh bag that we bought on Amazon. They're sterile. We threw the pulp in, we squeezed it out, and it takes a lot of force to do this. It does reduce if you put it into the KitchenAid, and that was really the point. My little small lady hands are not the strongest, and it's much easier for me to do this after it goes through the KitchenAid. Again, I can't show you the resulting pulp because it's behind my face, but that's okay. There's still a lot of pulp on those seeds when you hand pulp, which is unfortunate. So now we use the Roma, the second machine or technique we looked at was the Roma Processor. So there's multiple different types of these out there, and they are all marketed towards tomato processing. And the biggest thing is you have to convert the auger that is inside of here so that it can let the seeds out. So if you get one that's metal, you're going to have metal working tools then to modify it. But some people have those things. And we use the hand cranked version because the motor, I was borrowing Ron's machines. Ron told me the motor didn't work very reliably, so we used the hand crank. If you had gotten one that had a motor, these times would be slightly different. And then the Roma Coupe, we were able to use this machine but it is a commercial machine, so we were using commercial amounts of fruit. And you guys will be able to see the Roma Coupe in person and the processing lab later. You can see, this is the correct thing. The pulp comes out very, very consistent, no differences in texture, and then the seeds come out very clean. And that will vary depending on the fruit too. Sometimes they came out more clean, sometimes they came out less clean. It just depended on the fruit that we were processing. So again, we had different starting weights. This is in grams because it was just strange to put it in kilograms and grams. It was because we had 73 kilograms, right, for the Roma Coupe and 5 kilograms for the hand pulping, because I was not going to do 43 pounds of hand pulping. We did about 15, overall we did about 1,500 pounds of fruit last year. Wow. Plus other things that we did. So it was, to get replication on this experiment, it took a lot of fruit, and I'm so thankful for the growers who grow this fruit, because if we had to do that too, it would be a lot more work. But we were able to find, and again, I'm glad that's there, there was a significant difference between the tomato processor and the hand pulping in the Roma Coupe on recovery. Again, this is percent recovery, so we're taking into account that there are different starting weights. And then efficiency, the Roma tomato processor gained a little bit of efficiency, but it was significantly different. The Roma Coupe was significantly different from hand and the Roma because it increased the efficiency 3 times over. But there's a big but here, and that but is about almost $4 grand. So that is the problem. So, the Roma, the materials cost for the hand pulping is per bag, 50 cents to 10 to 11 cents per bag, depending on what you get. For the Roma processor, I could not find the specific one that I had anymore, but that just might be Amazon and the internet. But they range from $65 to $219. The Robot Coupe is somewhere around $3,600, but I'm not sure, they didn't give me an exact price. But, so it would be viable for commercial operations. And that's really what we are looking at here, is what is the market that you're marketing for. It does, so if we're just looking at dollars per pound here, I did a back of the envelope calculation to see with the efficiency and paying someone $10 an hour about how much it would cost you to pay that person with the efficiency per pound. So it's dollars per pound of how much it would cost. And it costs you $1.48 for the hand pulping, $1.11 for the Roma, and 40 cents per hour or per pound for the Robot Coupe. When you can get, the Robot Coupe can do 100 pounds in an hour. So you have to look at that trade-off. And then to add to the other calculations and trade-offs in your brain, pulp goes, our estimate on the pricing of pulp, which is only what we can do, is between $11 per pound and $22 per pound. But as the big disclaimer at the top says, I did not include the peeling time, the setup, the teardown, the storage in here, which is all massive. We, thankfully, especially for those times that we were doing 200-300 pounds of pulp, we had Gil, we had Matt, we had Joe, we had undergrads, we had extra help helping us peel all of that fruit, because we blanched all of this to go into the Roma Coupe to do all these experiments for this pulping last year. And thankfully we had the processing lab where we could have everything efficiently set up, and it wasn't my kitchen like it was in 2020. That was just Pawpaw everywhere. And it is an interesting calculation to be making in your head of looking at this in a full process. But moving forward, we are looking to add in a new peeling method, which is waxing. This has shown promise last year. We put a wax on the outside of the fruit, and it seems to stick to the peel, and it may be able to mechanize the peeling process, which is something that is not able to be done. The blanching also, we're going to have to figure out if that is the pulp that comes out of the Roma Coupe is a little bitter, and different people have different bitterness levels that they can tolerate, and some people are super sensitive to it, and they have said that the bitterness is just too much for them. We think it might be caused by the blanching. There's other hypotheses. It also could be the mesh size, so we're going to test the mesh size. We're also going to test if the blanching is the problem and just scoop some fruit into there instead. And we are looking at methods to reduce the enzymatic browning, because when the fruit comes out of storage, out of the freezer, wherever there's air, it will start to brown pretty quickly. And then we're also, with the help of Dr. Josh Blakesley and Horton Crop Science, going to do some flavor analysis, which is a lot of biochemistry that I don't understand. But, in summary, the most efficient method of peeling was blanching, the most efficient method of pulping was Roma Coupe, but the investment of labor and money need to be considered along with the size of the operation. And then the most important thing that I might have learned from Joe when I took his fruit class and met him is, what is your market? Knowing what your market is so that you can sell to the people that are actually going to be there for you, and you can develop that, is very important. So that is the end, and thank you so much for letting me talk.